No, sir. Why you didn't solve this? Austin?
I forgot, so sorry.
Okay, please do solve it.
Okay, sorry.
Also, I was just waiting. Austin, you also forgot to do it. Austin, have you solved it? Yes or no? Hmm. Hmm. Very easy question. It is very good. First, this is given. Now, according to the question, you can see this is given R is equal to K into A into B into C whole square. Concentration of C is doubled. When concentration of C is double, then rate will increase 4 times. Yes or no? Because when it will be 2 times, that means a square is there, so it becomes 4 times. Yes or no?
Yes.
So it will be for this, it will increase 4 times, increase 4 times. Concentration of A is half. When it will become half, the rate becomes half as well because directly proportional. Concentration of B and C are double. This is your double as well as this double. Since there is a square, so it becomes 4 times, and this is only double. So 2 into 4, the rate will become 8 times. Are you getting my point, both of you?
Yes, sir.
And concentration of A, B, C, and triple. That means if you are going to triple it, it will be 9 times. Then this is triple, and this is triple. 3 3 is 9, 9 is 81 times it will be. Yes or no? So this is you can, without writing it, you can solve it easily. Okay.
Yes.
Very good. There is one more question that I gave you. Did you do that? This question. You also didn't do this, right?
Yes.
Very bad. Just wait a minute. So in the next class, you are going to complete this. Okay. So I was talking about your rate law, find rate law expression. Unit of rate constant. Does anyone have any doubt in this unit of rate constant? Yes or no?
Yes. No, sir.
Hmm. This is also homework that I gave you. You didn't do it, right? Take it seriously. After a few months, your exams will be there, as well as JE will be there in January, February. And this means that after class, you don't revise at all, right? Austin and Humam. Are you getting my point? Yes or no?
Yes, sir.
You should just do it, because if you're not going to practice, how will you be able to do the questions in JE? Let me know when you are done with this. Any answer? Very good, Austin. Austin and Aman, please switch on your video as well. Order of reaction if you want to calculate. Okay, Aman. Austin. K is equal to the rate upon concentration raised to the power n. Rate has a unit, as I already told you, mole per liter per second. This will be mole per liter raised to the power. For the first one, it is -1/3. Now you just need to do simple maths. This is your mole per liter, mole raised to the power 1, and this is power. So this will be mole raised to the power -1/3 and liter raised to the power minus 1 minus minus plus 1/3. So after this, when you are going to calculate it, yeah, this is 1. So mole raised to the power 1 plus 1/3, it will be liter raised to the power -1 minus 1/3 per second. Just you need to solve this. So it will be mole raised to the power 4/3 and liter raised to the power -4/3 and per second. This is what you got, Austin. In the same way, B, C, D can be solved. Got it?
Yes.
Okay, can you do the rest at home? This is same. No, the concept is same. Okay.
Yes.
Okay. Moving to the next part, we are going to talk about characteristics of rate constant. So here it is. The value of K is used for determining whether rate is higher or slower. So basically, the reaction in which rate constant is high, that means the rate of reaction is high. So we can write here higher value of K. That means rate is very high. Rate is very high. and we can write lower value of K. That means the rate is slow. That rate is very slow. Is that clear? The next point is very important. The value of K is independent of concentration. The value of K is independent of concentration. Second factor, pressure of reactant, concentration of reactant and pressure of reactants. It only depends upon temperature. So please do write up to this, then let me know. You know when you're done with this.
Done.
No, still you're also done.
Yes.
The next we can write A depends on temperature. Generally, as the temperature rises, the value of k increases whether the reaction is endothermic or exothermic, whether the reaction is endothermic or exothermic, the value of K will increase directly proportional to temperature. Is that clear?
Yes.
Okay. Let me know when you are done with this.
Done.
Now, order of reaction. Now, we already know what is order of reaction. That comes from rate law expression. Now, we are going to study order of reaction. Now, you can see what is order of reaction. Again, I'm going to define it. It is the sum of powers of all concentration terms in rate equation, in rate equation or rate law expression. So basically in rate law expression or in rate law or in rate equation, whatever is the power of concentration, you know that in rate law expression that is concentration of reactant. Only we talk about in rate equation concentration of reactant, whatever their sum will be, you are going to add it and get the answer for order of reaction. The next point we can write, it may be either positive or you can write 0 or positive or negative. That means basically integer or positive negative fraction. So you have seen I have given example of 1, 2, 3 as well as 0 order as well as -1/3 order. So order can be anything, fraction, positive or negative integer or 0. It can be anything. but commonly that we use, it is of 0, 1, 2, or third order. Okay. Next point we can write. It is determined experimentally from rate law. It is determined experimentally from rate law. Please do write up to this. Let me know when you are done with this.
Done.
Austin.
Yes.
Okay. The most important point here is for an elementary reaction. Already explained what is elementary reaction, right? Oh, mom, what is elementary reaction? Reaction taking place in single state. In single state. That is your elementary reaction. So for an elementary reaction, order equals to sum of stoichiometric coefficient. Very important. Stoichiometric coefficient of the reactants, because rate law expression is defined in terms of in terms of reactant. So this is very important. Please do write it. For elementary reaction, the reaction which carries out in a single step, the order of reaction will be, you just need to add the simple. For example, let's say this is a elementary reaction. So order will be equal to what? Got it? Let me know when you're done with this. Are you done with this?
Yes.
These are some example of elementary reaction. If you are going to react H2 plus I2, you'll get 2HI. So tell me the order of reaction. That means N will be what for this? This is the first example, second example, and the third example I'm going to give you. H2O2 is there. If you are going to dissociate this, it will be converted into H2O plus half O2. So what will be the order of reaction for this? If it is a elementary reaction, tell me. Tell me, Austin Umamuddin. It will be equal to 2. What is the sum of stoichiometric coefficient of reactant? 1 plus 1, that is 2. Can anyone tell me, Umamuddin, what is the order of reaction for this?
1.
1 it is. Very good. So very it is easy it is if in the question or examiner told you that the following reactions are elementary reactions. So you just need to you just need to look at the coefficient of the reactants. If it is single, that means total coefficient of the reactant is the one with it is associated. Got it, both of you?
Yes.
Please do write it. And then this was for single step elementary reaction. Now for complex reactions, order can be determined from rate law only. Rate law only. And we know how to calculate for complex reaction as well, right? Yes or no? And then
Yes.
we are going to write the topic types of order of reaction. Let me know when you are done. Are you done with this?
Done, sir.
Very types of order of reaction in which we are going to study about the zero order first, then first order, zero order reaction. Now see, in zero order reaction, how you are going to write the rate law or rate law equation? R is equal to K into anything that is your reactant or product. First of all, I'm going to write it as rate. Rate is equal to A into reactant raised to the power zero. This will be your zero order reaction. Yes or no?
Yes.
Please do
Yes.
respond. Now, from this you can see rate is sorry, rate of reaction is independent of concentration of reactants. Rate is independent of concentration of reactant because this will be zero, that means one. So rate is independent of concentration of reactants. If we want to plot a graph, you can see the graph will be like this. This is your rate versus concentration. This is your concentration. So it will be a parallel line. It does not depend upon the, it does not depend upon the concentration. Like this, the graph will. Okay. And you already found that unit of rate constant is what? Mole per liter per second for K. Please to write. Just wait a minute. I'll be back from this.
Done.
Very good. Now see, I'm going to give you some example of zero order reaction that you should keep it in mind. Example, that is your photochemical reaction. Photochemical reaction in the presence of H nu, that means or light, sunlight, you will get 2HCl. So basically this is your zero order reaction. And hence we can also write a point that is here rate is directly proportional to intensity of light. If a reaction is written in a single line, that doesn't mean it is a reverse. It is a it is an elementary reaction. Okay, so here you should also keep this in mind. Rate will be directly proportional to intensity of light. The second example we can take is decomposition of substance on the surface of matter. Surface of matter. So what will be the example here? I'm gonna show you. You are going to react this 2HI on the surface of gold metal AU surface. This is also an example of zero order reaction. H2 plus I2. If you are going to decompose this NH3 on the same surface, gold surface, you will be getting N2 plus 3H2. So basically, I can also write here that the rate is directly proportional to surface area of matter. If surface area of metal you are going to increase, rate of the reaction will also increase. Okay. Right. Let me know on your comments.
Done, sir.
Okay. Very good. Now we are going to start the integrated rate equation that we call it kinetics. Kinetics. That means basically integrated rate law. Integrated rate law. So first of all, zero order reaction we have started. So let's say A is converting into product. So first of all, I'm going to write the rate I can write in two terms. Rate is equal to either I can write d of A upon dt minus d of A upon dt, or since it is zero order reaction, we are studying for zero order reaction. So rate can also be written as k into e raised to the power 0. Yes or no? Please tell me.
Yes.
So what I'm going to do, both are rate, right? Both are rate. So can I, first of all, just wait a minute. Let's say at t equals to 0, when the reaction did not start, is about to start, the concentration of A is A naught. The concentration of A is A naught and concentration of product is 0. At t equals to t, at t equals to t, the concentration of A becomes AT. We don't need to do anything with product, so it's not necessary to determine the product. Now, what I want to say, both are for a rate expression. So can I write minus d of A upon dt will be equal to k into r raised to the, A raised to the power 0. Can I write this?
Yes.
Both are rate expression. Now, what I need to do is very simple. So what I'm going to do, d of A is equal to, I'm going, just wait a minute, k into A raised to the power 0. That means what? This will be equal to 1. And I'm going to multiply this to this side, k dt. And now I'm going to do the negative sign, multiply this equation with negative. So it will be positive and this will become negative. And I'm going to integrate from t equals to 0 to t. And here I'm going to integrate from A naught to AT. Is there any problem? This is just the derivation. The derivation won't come in the exam, but the process is important. Are you getting my point?
Yes.
No. Can anyone tell me what is the integration of dA? dA will have integration A from A naught to AT and K dt. You know that this will have integration minus KT. K is constant 0 to T. I can write this. Now, after substituting the value of lower limit and upper limit, KT will be equal to minus KT will be equal to concentration at time t minus concentration at time t equals to 0. And I'm going to multiply with minus in the whole quantity. This will be positive, this will be negative. That means this is your initial concentration minus this will be your final concentration. In the same way, if you want to calculate K, so this will be the formula. Initial concentration minus final concentration divided by time taken between them. Is that clear?
Yes.
Please do write it. Let me know when you are done with this.
Done, sir.
Very good. Now, this can be also, this is the formula. K is equal to initial concentration, A naught minus final concentration, AT divided by time taken. Or this can be written as now let's see. K is equal to initial concentration as it is. The final concentration is basically the final concentration is initial minus something. This X will come from the initial, right? It will be dissociated or comes from here. So this and this will be cancelled. So K can be written as X by T. X is the final. X by T. This from this you can write this, right? Very easy. This is to write. We can also draw a graph between concentration, final concentration and time. You can see this was what we got. KT is equal to A naught minus AT. A naught minus AT. Now you can see that this is your y-axis and time is your x-axis, which is directly proportional, and there is negative sign. That means the graph will be downward. Okay. Intercept here is your initial concentration, A naught. And if you're going for what we say slope will be what? Minus, you can say minus. You just need to reverse this. You will get it. Basically, you will get A T is equal to A naught minus KT. A naught minus KT. And this is your y directly proportional to T. That means x minus. This is your mx. M means slope. And A naught is what? Plus C. That is your intercept. Y is equal to mx plus C. No, no. Are you done with this?
Done soon.
Very good. So this formula you should remember or this as well. Now, half-life. See, half-life, that is T half we denote with it, half-life period. Whatever is the concentration of reactant, let's say there is A to B. Initially, it is 100 molarity or 100 gram, and it becomes 50 molarity or 50 gram. Whatever is this, the time taken to disintegrate or convert into 50% of the initial, that is your half-life. From B to C, if it becomes 25 m, that is your half-life. Are you getting my point? If you have 100 kg of anything and you finished in 5 hours 50 kg, that means basically that 5 hours will be the half-life. Is that clear, both of you?
Yes.
So I'm going to define it. The time taken for the reactant concentration to become half of its initial, to become half of its initial. The final concentration should be half of its initial. Let's say there is 1 gram or 10 gram, and it is now 5 gram. This is your half-life. Okay. Now, after some time, it becomes 2.5 gram. This is your half-life for this state. After some times, it becomes how much? 1.25 gram. This is half-life. The time taken to come to do this. Okay. So for zero order, we can apply, you know that K is equal to initial concentration A naught minus final concentration AT divided by time taken T. So can I write T is equal to A naught minus AT final concentration divided by K. So if I'm going to put it here, T half, this will be equal to initial concentration will be as it is A naught, but the final concentration should be half of initial, yes or no? The final concentration for half-life will be half of initial concentration, and this will be K. So what you will get after solving it, you will get A naught by 2K. That means basically T half of zero order reaction as a formula, that is A naught upon 2K. First, you are going to write it. Then I will give more concept about this, which is very easy. Let me know when you are done with this. Are you done with this?
Yes, sir, done.
Okay. Now see, this is the formula for half-life, which you have seen. T half is equal to A naught upon 2K. A naught is the initial concentration. From this formula, you can see T half is directly proportional to the initial concentration. So we can write T half of zero order. This is important. Zero order reaction is directly proportional to initial concentration of reactant, initial concentration of reactant. These two, right? And in the same way, we can plot a graph as well. See, this will be your graph. Between what? So this is your initial concentration, and this is your T half. So they are directly proportional to each other. So the graph will start from origin. Origin. And here the slope will be what? Slope will be equal to 2K. How I'm calculating it? So you can say you just need to multiply this. This is your A naught and this will be equal to 2K into T half. So this is what? This is your Y directly proportional to this is your X positive. That means upward, positive, directly proportional, a straight line, positive, upward. And you know that Y is equal to mx plus C. C is 0. That's why it starts from origin. M is the slope, which is 2K. Is that clear?
Yes, sir.
Is to write it. Let me know when you are done. Let me know when you are done with this. And always attempt the assessment test after class.
Done, sir.
Okay. You are also done, right? Austin,
Yes.
first order reaction. Reaction is stand for reaction. So if there is a reaction A to P, first of all, so rate how you are going to write it, rate will be equal to A into A raised to the power 1. This power defines it as first order reaction. Now, if you want to plot a graph, rate versus concentration, you can see this is your rate versus concentration. R is concentration. This is your concentration. So you can see it is directly proportional. So the graph will be a straight line because you can see rate is directly proportional to A. In the previous one, it was A raised to the power 0. That's why it was independent of reactant. It was independent of reactant of concentration. Example, I'm going to write it. Some example that you need to take care. That is equal to decomposition of. These are all first order reaction. Decomposition of hydrogen peroxide H2O2. When you are going to give heat, it will be converted into 2H2O plus half O2. N2O5. This is also 2N2O5. This is also, if you are going to break this, you will get 4NO2 plus O2. This is also your first order reaction. NH4NO2. If you are going to break this with the help of heat, then this is also your first order reaction. NH4NO3. This is also your first order reaction. Will be converted into N2O plus 2H2. Please do write this. These are all example of first order reaction. Let me know when you're done with this.